Hi guys, welcome to my next set of theory videos. In this set of theory videos, guys, I'm going to be covering the functions that I think that are most important in the study of calculus. So I'm going to go over some functions, give you properties about them, and then that's pretty much it. And then we'll solve problems using these functions. Okay, so I'll start with the linear function. A linear function is a function in the form of y is equal to m times x plus b. Um, m dictates the speed at which y changes as x increases. B dictates when the line intersects the y-axis. So x is equal to 0 at that time. Okay, so in some properties is the domain of a linear function is minus infinity to infinity, and the range of a linear function is also minus infinity to infinity. Okay, so that's two properties of a linear function. Um, what else? Okay, so for here, let's try to express what we see in this graph. Okay, so the b for all the lines in all these lines in this graph is equal to 0. Okay, why is it equal to 0? Because when they intersect they intersect the y-axis, and at the point that they intersected is 0. Okay, so because of that, b is equal to 0. And what is the m? Well, the m we can estimate. So the m could be in this, for this first line, could be 3 over 2. The m in this line could be 1, and the m in this line could be minus a half. Why minus a half? Because as x increases, y decreases. So for that reason, m has to be negative. And because this is 1 and and it's increasing faster than this is decreasing, I made this minus a half just to show it's decreasing lower. Okay, so that's one form of a linear function. This is also a linear function, guys. Here, m is actually equal to 0, right? Because there is no change in the function as x increases. And b in this line is equal to where the y-intercepts. So we could assume that this is 3 over 2. Okay, so the b here is 3. So the function in this case would just simply be y is equal to 3 over 2. Okay, because and there's no change. It's going to be like this in all the x-axis. Okay, that's it, guys. So let's move on. That's basically what a linear function is. Now let's move on to another type of functions called power functions. Okay. Hey guys, the next thing I'm going to cover is power functions. Power functions are functions in the form f of x is equal to x of a, where a is a constant. This is a power function, okay? So I'm going to break down my coverage of power functions in 3 segments. The case where a is greater than 0 and a is even, the case where a is greater than 0 and a is odd, and the case where a is less than 0. And I'll cover even and odd at the same time when the case is a is less than 0. Okay, so let's start by power functions. So as we can see, some examples of power functions are x squared, x to the 4, x to the third, x to the fifth. Okay, these are all power functions. Now, the domain of the power function when a is greater than 0 and a is even is minus infinity to infinity. Okay, so let me change the color. Minus infinity to infinity. Okay, it's defined for all real numbers. Okay, what is the range of f of x? Well, when a is even, this is between 0 inclusively to positive infinity, right? Because as we very well know by now, um, x squared, okay? Whenever we put a negative value into it, we're going to get a positive value back, okay? So the range is always positive. Now x to the 4, I don't think we saw it before, but x to the 4 is also going to guarantee us to have a positive value. So basically any even a is going to guarantee a positive number return for whatever value of x we put in. So for this reason, um, when a is even, the range is between 0 and infinity. Okay? So now let's consider the case where a is greater than 0 and a is odd. Okay? So when a is greater than 0 and a is odd, the domain is still minus infinity to infinity. Okay? Because you could put whatever value of x in there. But the range also is minus infinity to infinity because as we've seen before as well, x cubed returns a negative value when we put in a negative value and a positive value when we put in a positive value. The same is true for any x to the power a where a is odd, okay? One interesting thing to note, guys, is as the power increases in power functions, okay, between the interval -1 to 1, we're going to notice that the curve gets flatter as a increases, okay? So in the interval -1, let me fix that, -1 to 1, as a increases, we become flatter. Function gets function f of x becomes flatter. Why do you guys think this is it? This is the case? Please let me know down in the comment section why you think. You could try plugging in some numbers for different values of a, and you're going to notice this behavior. And put down in the comment section why you think that is, and I'll answer a few of them. And you could, of course, discuss it amongst your colleagues in the comment section as well. Okay. Now let's move on to the case where a is less than 0. Okay guys, so now let's look at the case where a is less than 0. When a is less than 0, this property could hold, okay? X to the a is equal to 1 over x to the minus a. So let's consider the case a is equal to the -1. So f of x is equal to x to the -1, which is equal to 1 over x. Okay, so what can we say about functions when a is less than or 0 and the value of a is odd? Okay, so in those cases, the domain of the function is from -infinity to 0, union 0 to infinity. Why can it not be 0? Well, because if it's 0, we have 0 in the denominator, and this is not allowed. It's an undefined, undetermined form, right? So we cannot have 0 in the denominator, and for that reason, the domain is -infinity to 0, union 0 to infinity. And the range is also the same as the domain in this case. It's -infinity to 0, union, let me clean that up, union 0 to infinity, okay? So that's the case when a is less than 0 and a is odd. Okay, so now let's look at the case when a is greater than 0. A is less than 0 and a is even. So f of x is equal to -2. So we use the same property to make it 1 over x squared. So once again, the domain cannot equal 0, right? Because we'll have a 0 in the denominator. But also notice that the range cannot be negative, right? Because x squared, when you put any value of x in there, it's going to become a positive value. So the range cannot be negative. So the range in this case is 0 to positive infinity, and the domain is still the same as the case of the odd. So -infinity to 0, because it can't include 0, union 0 to positive infinity. Okay, so that's it, guys. So that's my intro video on important functions in the study of calculus. Um, that's just a theory video. I just tried to get straight to the point and explain to you some common functions that we're going to see. So in the next video, I'm going to cover polynomial functions and rational functions. Okay, thank you for listening and catch you in the next one. If you have any questions, please don't hesitate to put them down in the comment section below. Thank you.